Welcome. Today's presentation will be focused on migrating your monolithic software architectures to a distributed service environment. This is a process that is being undertaken more and more by organizations these days, and hopefully we will be able to provide you with some guidance and tips on how to successfully plan and execute these types of migrations. First off, some introductions. My name is Andrew. I am a solutions engineer at Lightstep. Prior to this, I spent time at New Relic and other software companies and have over the years helped companies on their observability journeys in both monolithic as well as distributed software architectures. So for today's webinar, we will be going through an example migration process. During this discussion, we will talk about the overall strategy for the migration, how to use observability to de-risk the move, and then also how to use observability once you have moved into this microservice world and what it would mean. So let's assume that we are starting off with a monolithic e-commerce application that's illustrated here. You may have done a lift and shift migration of that service from bare metal or VMs into Kubernetes, but the service itself is still monolithic. It still contains the code functionality for everything from handling logins, authentications, all the way to shopping carts and payment systems. So if one of these functional areas suddenly sees an increase in traffic, such as many more users logging in, there is no way to scale up just that functionality to handle the increased volume. You would have to scale up the entire application instead. This would not be an efficient usage of your Kubernetes infrastructure resources. Usually, when you're starting out development, monolithic architectures can have some benefits in improving development velocity because all the code is in one place. Eventually, though, this starts breaking down as you introduce more functionality to your application and it becomes more complex. Monolithic architectures have a harder time adapting to increased traffic volumes or different traffic patterns. As you scale up your engineering teams, it becomes more difficult and slower organizationally for all these engineers to work on the same code base at the same time. Because of these reasons, many companies today are looking to decompose their existing monoliths into distributed services. The goal of today's exercise is to split out our payments functionality into its own microservice and to integrate that service with a new third-party payment endpoint. We want to accomplish this with minimal disruption to the overall business. So this diagram illustrates the end state desired. In this example, the payment functionality has been broken apart into its own microservice with no downtime and no interruption of service for the end user. A new third-party payment processor has also been integrated. The practical business result is no revenue is lost because of this migration. As you can see, some of the third-party calls are shared by two services. Cart storage and authentication are still hitting the same endpoints. This is not a problem though, because we can simply use a shared library for calling these endpoints. But because the payment calls themselves are now split into a separate service, it can be horizontally scaled independent of the main service, and development of the new payment service is now decoupled from the main service, helping increase development velocities for both. So let's talk through the migration process. We know that we want to separate the payment functionality from the main monolith. We want the new service to be horizontally scalable, integrate a new third-party payment processor, and simply operate asynchronously from the rest of the stack. In order to achieve this, let's talk through some of our considerations and tips that one should take. First off, we recommend defining must-have upfront, and then also start thinking about the appropriate SLOs around them. We don't want to approach this migration blindly, and there's no way to know whether we've achieved success unless we have a way of measuring. So some examples of must-haves based on what we've already mentioned are things like scalability, reliability, integration to a third-party endpoint, and zero downtime. And here, zero downtime really means not affecting any upstream services during migration, and more importantly, not affecting any end users. So let's discuss a bit about SLOs, or service level objectives. Sometimes these are referred to as SLAs or SLIs, service level agreements or indicators, but they essentially measure the same things. Everyone has opinions on what should be measured and what is important, but we have some tips and suggestions based on our experiences. Upstream SLOs define a performance and reliability contract with the upstream service that relies on you. That's relatively straightforward. Downstream SLOs define expectations for services that you rely on. Oftentimes, these will be services that you have no control over, but are dependent on for achieving your own SLOs. Defining this SLO protects your team from blame, allowing you to clearly differentiate if a performance issue is caused by your own service or some downstream service. Defining executive level SLOs are also important. What does your business leadership care about? These measures are usually tied to the business value provided by your services and may or may not be exactly the same as the SLOs that you define at the service level. Ultimately, your application is there to serve your customers, so it's important that your internal service SLOs conform to your business objectives. You can use observability systems that leverage distributed tracing to help define and measure these goals. Distributed tracing is useful here because it provides the context necessary to measure these objectives. So here's an example of how you might go about defining your SLOs. The business critical SLO here is that when an end user clicks the pay button, the payment executes without errors and quickly. Your own payment service is directly called by the business critical operation. It might also be called by other services. This is where you would define your service's SLO in terms of response times, uptimes, and error rates. Thirdly, your service will be calling downstream providers such as the payment processor, authentication processor, or your cart storage. It is useful to define your service expectations of performance and reliability for these downstream services as well. So some examples of SLAs would be things like, alert when a third-party payment service has an error rate of greater than 0.1%, or alert when the payment endpoint's P99 latency is greater than 5 seconds. These are just examples of what you may want to define as your SLOs. So next, let's talk a bit about operations. These are all areas you might want to consider before starting your migration. These include things like containerization, configuration management, CI/CD, etc. Once you start creating one service, you will want to create more, and having a well-established, repeatable, and reliable process for standing up containers and configurations will help speed this process along and gain confidence. Also, you will want to do some rough cost estimation for some of the components in your call stack. For example, you don't want to find out 6 months down the road that you can no longer call your third-party payment service because they are too expensive for your scale. You will want to know these types of things ahead of time because it will affect your overall architectural decisions. Another thing that might be obvious is that you should stick with languages you are familiar with, unless there's a very good reason not to. This helps standardize the knowledge base set across your organization. We've seen companies that are pretty open to allowing their different teams to do pretty much whatever they want. And although this will probably make the teams happy in the short term, it becomes more difficult to maintain long term. Teams change, people leave, someone else will eventually own that service, and if they are not familiar with the language, it will become much more difficult to maintain. One other question that is often asked is when one should use serverless functions, like Lambda. This really depends on how familiar your team is with the technology and how complex your business logic is, especially if the logic is stateful. The ephemeral nature of serverless functions makes it difficult to maintain state in these very short-lived functions. And if your developers are not experienced with using serverless functions, it also becomes a steeper learning curve. One thing to consider is the typical response time of your calls. If they are greater than 30 seconds, I would not recommend using serverless functions because they tend to have timeouts which are around the 30-second range and can cause all sorts of problems if your operations need to run longer than that. These types of scenarios are probably better served using short-lived containers like Fargate or a small microservice. So next up, let's talk about API contracts. How is this service going to interact with the outside world? The easiest thing is that if the contract doesn't change. We know that's probably not realistic because when you do something like breaking the payment service out of your monolith, you may also want to change the API interaction from, say, an XML endpoint to a REST one. Providing the API contract early allows teams that depend on your service to start their dependency changes sooner, as well as not have to wait until you finish your development. If you have time, we would recommend using something like Swagger to enforce your API stability. There are also tools that help integrate Swagger into your code base, so your API definitions live right next to your code. This helps enforce API stability, as well as letting everyone know the status of your API definitions as you're building them. I would also recommend understanding and diagramming the existing behaviors within your monolith, so you can understand existing behavior patterns and current performance limitations. You can then build these into your must-have list for your new microservice. That way, you can ensure that your service behaves and performs at least as well as your existing monolithic code. This is something where observability systems leveraging tracing can really help because it will show you these code paths in your existing monolith, as well as the same behavior in your new microservice. Without tracing, this is very difficult to do because looking through log files and metrics won't be able to tell you if certain methods or components are being called and in what situations. So next up in your migration discussion is talking about data flows. Thinking about data models. This new third-party payment processor that we're integrating with, what is the data model and business logic of this service? Will we need to create any data transformations to connect to this new service? What are the external infrastructure components that we will need for this new service? Is this something that we are familiar with and how to operate, or is this something new? It may be worthwhile to take a sprint to understand these behaviors. Ultimately, this is about de-risking the migration. So one tip is to brainstorm these risks early. For example, if you're planning on using a new database, what is the infrastructure required for running it? What are its throughput capabilities? What are its performance profiles? Spending time benchmarking and analyzing this new system, as well as your current system, will help de-risk the move by having a better understanding of the capabilities of the components so you can design for its strengths and limitations. This will also allow you to create management plans and playbooks for working with these new systems. Another tip is to plan how your migration to the new microservice will happen, as well as planning for that plan to fail. Will you migrate a percentage of your traffic at a time, one endpoint at a time, all at once? What constitutes done for your migration? What happens if things fail? How will you roll back to your previous state? How will you roll back during each state of your migration? How would you completely roll back to your monolith if for some reason this new service doesn't work? All these considerations and plans will help contribute to zero downtime goal of your migration and simply a smooth transition. So those were all the things I wanted to discuss regarding the migration from your monolith to microservices. Next, we want to discuss what sorts of effects a microservice architecture has on your systems. As a number of services grow, the complexity of your system grows. Your team may only have control over one or few services, but your own SLOs that you are responsible for are affected by an ever-growing list of teams and services downstream from you. These are services and components that you have no control over and may not even know about. How do we understand where the responsibility falls in this situation? The answer is that this is more of an observability challenge. In a microservice migration, you're introducing more complexity into your system. You are going from a single monolith where it's relatively easy to reason about its behavior patterns to more and more services that interact with each other but are distributed and decoupled. This also introduces more points of failure in the system because you are making more and more inter-service network calls, as well as spreading these services out to external services. Say your monolith is calling a MySQL database. Because it's only one service calling a database, it's relatively easy to understand traffic patterns. All the calls are coming from this one service. But if you now have 10 different services, some calling the database and others not, it will become more difficult to understand the traffic to that database and where the load and bottlenecks are coming from, since they are now coming from multiple services, each with their own behavior patterns. Let's take a look at an example from our system. What you see here is a service diagram from one of Lightstep's actual customers. Lightstep is an observability tool that ingests distributed tracing data along with other data sources. Using this distributed tracing data, we dynamically construct these service dependency views of your systems. So looking here, your team may own, say, the service that's here on the top left with the blue dot. But as you can see, that service is actually dependent on a large number of downstream services to complete its work. Now, this is a somewhat extreme example of service complexity, but this is exactly the type of thing that happens when you start going down the path of microservices. System complexity, system depth, system interdependencies, all of these things increase. Here's another example. The service with the blue dot is the service you own. But as you can see, the service has multiple upstream as well as downstream dependencies. And as that complexity grows, we oftentimes see this type of behavior in the bottom where the depth of service calls also grow. The growth eventually gets to a point where it is no longer possible for a human to understand the transactional logic going on. You have to start relying on observability systems to generate these types of dependency maps. Even then, it becomes more and more difficult to understand your individual API call stack just by looking at this map. Using an observability tool with distributed tracing can help. A lot of people think of this type of observability as useful once you have already migrated to the microservice environment. We think that it is important to start with your monolith because it will help de-risk your migration in several areas. The first I want to discuss is around code complexity. Monitoring and tracing your monolith will help you understand and identify your code paths, which will need to migrate to this new microservice. Using tracing, we can see what these code paths actually are. Once the code is migrated, we can use tracing to see if the deprecated code paths in the monolith are actually deprecated and no longer being exercised. Without this visibility, you could not have the confidence to remove this old code from your monolith, leaving behind zombie functionality because you can never be sure that it is no longer needed. Thirdly, visibility during deployments will help you ensure that we do not introduce unexpected regression back to these old code paths. So next, de-risking for performance regressions. Your observability tool will also help identify performance regression in your monolith and your new microservice by collecting the golden signals of response times, error rates, and throughput. This allows you to ensure proper performance of your services, giving you confidence that you are fulfilling your API contract to your upstream services. It also allows you to collect the same telemetry for your downstream service and external third-party calls, thereby allowing you to hold them accountable for their service contracts. Finally, de-risking for external dependencies. Observability systems will help your developers to see the performance of their new services as they are being built. It will provide them with real-time performance information on their own services, as well as external dependencies that they are calling. This allows the developers to verify that their external services are actually responding, as well as collect the performance metrics for these services to understand whether they are behaving as expected. Then, wrapping these new calls into easily debuggable and understandable SLOs will give everyone a clear picture as to the state of your systems before migration as well as after. After all, you do not want your new microservice to perform worse than your monolith. Otherwise, what's the point of migrating? Well, that's all I wanted to touch on regarding your monolith to microservice migration. A quick plug here. Lightstep is an observability platform and is built to handle all of these de-risking tasks. We have specific workflows for analyzing deployments, regressions, and dynamic service and operation dependencies, and can provide the visibility necessary to achieve a successful microservice migration. We have deep experience in helping our customers with observability through their monolith decomposition journey. So please feel free to reach out to us. My email is at the top of this presentation, and we would be happy to help. Also, please join myself or one of my colleagues at the Network Chat Lounge following this with any further questions. Thank you.